Hi, welcome to the fourth video in the series. So, remember in the last video we had to move this whole chunk of code down here because it was blocking us? Well, I've actually got a better solution for this problem instead of just moving it down here. So what I'm going to use is something called a non-blocking socket. So at the moment, the way our sockets are behaving is in a blocking structure. So every time we send a message, it's going to wait for the reply. So it's always waiting for the next thing to happen, and it's very linear and not parallel. So to make a more parallel code, more of a parallel code, what I'm going to do is I'm going to use something called non-blocking sockets. So I'm going to set the blocking to false. Now notice if I put this back up again, so I'm going to do Control X. It's no longer going to block us from getting our input from the client. So I'm going to save this. And actually I'm going to put another thing here. So if our client message, so whatever we just entered, is equal to quit, then I'm going to say sys.exit. Oops, exit. And as you can see, I've imported sys here, so you might want to do that. So yeah, that just gives me an easy way to quit the application instead of closing the terminal completely and reopening the terminal. Okay, so let's try this out. I'm going to save this, and in here I'm going to say by client, and non-blocking socket operation could not complete. Okay. So what I'm going to have to do actually is put this whole thing in another while loop. It's going to look a bit weird, but that just puts it so it's no longer going to be immediately the immediate operation in our code structure. So I'm going to do a try actually, and in the try I'm going to put the while true. I'm just going to change the indentation here, and for the accept I'm just going to say pass for now. So if I run this again, I'm going to say hi. It's going to ask me to enter something again. I'm going to say something like whatever, and notice it took me two inputs to get one output. So if I say something again, Joe, it gave me two outputs. So you can see it's not, so when you make something parallel, you no longer know when you might get something back. So if my server is like really slow, I might get the replies back even much later than what I'm getting right now. So that's one problem with parallel coding or non-blocking coding. So the way I'm going to fix this is I'm going to set the blocking right after I enter my command. So I know I'm expecting something back at that point, so I'm going to turn the blocking on. But as soon as I've received my reply back, I'm going to turn the blocking off. So what I'm going to do here is this is where I just entered my command. So I'm expecting something back here. So as soon as I send my message to the server, I'm going to turn the blocking off. Set blocking, and I'm going to say that's true. And as soon as I get my reply back from the server, I'm going to say set the blocking off. And that's going to be false. Save. And yeah, that should work. So right here, I'm going to use my ft command quit and to quit the application. And now I'm going to run the thing. So pi client. Oops. People are messaging me. So let's say hi, and as you can see, I received the reply back from the server immediately. I'm going to say yo. So as soon as I send my command to the server, it's going to wait for the server to send me back the response, and as soon as I've received the response, it's going to set the program back to parallel structure, so I can do multiple things at once. So if this wasn't set to blocking, if this blocking was set to true, then notice I'm using a while true loop here. So it's my program's actually going to get stuck in this while true loop instead of actually going to this bit here. So the fact that we're setting it to non-blocking is allowing us to jump out of this while true loop and process whatever's going out here. So that's going to be about it for this video, and let me know about any questions or anything down in the comments, and thanks for